Okay, let us start with the topic photoelectric effect. So here we have considered photosensitive surface, right? And we have incident light, which means photons. When the light of suitable frequency falls on photosensitive surface, right, then there is a ejection of electron from the metal surface, and this phenomenon is known as photoelectric effect. So again I repeat, when a light of suitable frequency falls on the photosensitive surface, then the electrons are ejected from the metal surface, known as photoelectric effect, and the emitted electrons are called photoelectrons, right? And due to this electron we will have a current known as photocurrent. Now there is some experimental observation based on photoelectric effect. We have considered a tube which is vacuum, considered to be vacuum, but it is not perfectly vacuum, and we have considered one source of light. Fine. And from the light, photon comes and then hit the, let's say, cathode or this plate BC. Here we have one potential divider, right? Potential divider has an arrow, you can see it. If this arrow is near this end, so we can say that this is near to negative. So which means that this plate will be negative. The other arrow is near what? Near positive. Then this will be positive. Had been the case that if I shift this arrow here, then this plate will be what? Positive, and this plate will be negative. Okay, so this is a potential divider by which we can change the polarity of the plate and even the voltage. Am I clear? So now what happens, as the light from the source comes out and falls on the metal surface, it hits the metal surface and then it emits or ejects out electron, right? And because of this potential difference, this being negative, this being positive, the electron here are accelerated, will move towards the positive because electron being negative. As they move, they give rise to current, and that is measured by this microammeter, right?
Yes, sir.
Now, and this voltmeter will measure the voltage across this two plate. Now we have to see certain observation, like the first is effect of intensity with respect to effect of intensity on the photoelectric current. How your photoelectric current changes for a given intensity or for change in intensity. As we increase the intensity, fine, how does photoelectric current changes? So here, how to increase intensity? First question. To increase the intensity, what we do is that we bring this source closer. So by bringing the source closer, basically the photons which are falling on the surface increases, and due to which more electrons comes out. Let's say that initially intensity is such that there are 3 photons. Let's say because of this 3 photon, there is emission of 1 electron. But if I increase the intensity, increasing intensity, again I repeat, means that more photons are falling on it. If more photons are falling on it, which means there is probability of more electrons coming out. So it is very obvious that if I increase the intensity, our photoelectric current also increases. Is it okay? So now you must know the definition of intensity for your examination. Intensity is also defined as energy per unit area per unit time. So energy per time means it is a power, right? It is a power. So power by area. So unit will be watt per meter square. You must know this, okay? Because many times in examination they have also asked the unit for intensity. Now next case, here effect of potential on obviously photoelectric current. So this is your current, right? Now here what I do is, let us say I have taken 1 volt. So electron will accelerate. Now if I take 2 volt, electron will further accelerate with a large velocity. So if I keep increasing the voltage, which means the electrons will keep moving with higher kinetic energy. Yes? So due to which current also increases. So here you can see in the graph, suppose if I take positive potential, so with the increase in potential, photoelectric current also increases. But as per the graph, we can see that it gets what? Saturated. Which means with the increase in voltage, your photoelectric current does not increase. Maybe there are many factors due to which the kinetic energy of electron does not increase continuously. Maybe there are air particles inside. As the kinetic energy increases, they might collide more with the air particle present, and that offers a resistance, and hence we cannot increase the current beyond certain limit, even if we increase the voltage. Okay, so even if I increase the voltage, right, electron might not continuously increase its kinetic energy, and hence the current gets what? Saturated. So that's the reason in the graph here. So with the increase in potential, initially it increases, but it gets what? Saturated for a given intensity. Right? Now, if I say this plate, see now this plate is negative and positive. Suppose I reverse the polarity. I make this positive and this negative. Correct? The electrons which we are going, what will happen to this electron? So electron is negative. Now this plate is what? Positive. So this electron now will get deaccelerated. Why? Because positive will attract negative. So this electron will slow down. Supposing if I first give minus 1 volt, okay, negative voltage. So with respect to the previous polarity, now the polarity is, this is what? Negative. Sorry, this is your positive and this is your negative. So with respect to previous polarity, this is opposite now I am considering, due to which electron will get what? Deaccelerated. Why? Electron is negative, I repeat, and this is positive now. So electron will have less velocity now. So if I keep increasing the voltage, let's say minus 1, minus 2, fine, electron will keep deaccelerating. Right? Now if I apply, let's suppose say 3 volt. In that case, light is coming and hitting the electron. Right? Now electron is supposed to go out, but here I am giving, let's say 3 volt, which is enough to hold back this electron. Understood? So this potential which I am giving to the plate, which will hold back the electron, which will not allow the electron to go out, that potential is known as stopping potential. So I can say that stopping potential, fine, if I apply, the electron will not come out of the surface and there is no current. So what is stopping potential? It is that negative potential for which there is no photoelectric effect. Now why? Because this potential which I am applying here, negative potential 3 volt, is enough to hold back the electron on the surface. In order to, let's say, electron to go out, they have to supply more energy to the electron, then only they can go out, otherwise not. So we have come across new definition, new term, that is stopping potential. So what is that? It is that negative potential for which there is no photoelectric effect. Right? So here you can see in the graph, see, if I apply a negative potential, keep increasing, then a voltage is found when the current is what? 0. So this negative potential is known as stopping potential. So very important definition for your examination. They might ask you. Stopping potential is that negative potential for which there is no photoelectric current or electron does not come out of the metal surface. Now, if I increase the intensity, they say, what will happen to stopping potential if I increase the intensity? See here, now, supposingly I am using 3 photons, right? And has an energy, let's say, 2 electron volt. But here I am applying 3 volt, which will give energy of 3 electron volt. Now this 3 electron volt can easily stop the what? This electron going out of the metal surface. Why? because photon will give just 2 electron volt, and that is not enough to overcome, let's say, 3 electron volt. Understood? So my stopping potential, let's say, is 3 volt. Now if I increase the intensity, what does it mean? Increasing of intensity means you are just increasing number of photon. You're not increasing energy. What are you increasing? Number of photon. Okay. So photon will receive the same amount of energy as it was receiving before, that is 2 electron volt. Because increasing of intensity, just it means just increase of number of photon. That does not increase the energy of photon. So which means that electron will receive same energy as before, even though we have increased the intensity. Right? So this is clear. Now see, now why it is independent of intensity, let's say. So see, in case of photoelectric effect, we are talking about particle nature of light, and in case of particle nature of light, fine, even if I increase the number of photon, this electron will be hit by just one photon only. Other photon cannot hit. This is one-to-one interaction. Fine. Had been the case that, okay, one photon is hitting, other is hitting, so continuously it is getting more energy.
Yes.
But this is not happening in this case, as per this photoelectric effect. Because as per photoelectric effect, we are studying a particle nature of light, where we study about one-to-one interaction. So due to which they gain the same 2 electron volt as they were gaining before. Okay, even if I increase the intensity. So which means that even if I increase the intensity, my stopping potential remains to be what? Same. So this is very important point for your examination point of view. That is, stopping potential is independent of intensity. This is a point to remember. This point to remember.
Yes, sir.
Right? Now, what about frequency now? What about
Frequency?
Suppose this is a plate, there is an electron. Before it was, frequency is given by h nu.
Yes, sir.
If I increase frequency, energy will also increase. Before it was 2 electron volt. Now let's say it is getting 4 electron volt because of increase of frequency. Now electron will get how many? How much? 4 electron volt.
Yes, sir.
How much voltage I applied before? Let's say 3.
3.
Right? 3 electron volt. And with the increase in frequency, fine, it is getting 4 electron volt.
Yes,
Now will this 3 electron volt be able to stop this electron? Answer is no.
no.
It will go out. But to stop, how much at least you should apply?
But then you said 3 electron volt can stop, no?
3 electron volt can stop what? 2, no? Before it was, electron was having energy which is 2 electron volt, and 3 electron volt could stop that.
Wow.
Now what I am doing?
4.
Now what I am doing? I am increasing the what? Frequency. As I increase the frequency, fine, the energy will also increase for the photon. Let's say I said 4 electron volt. Now the electron has energy equals to 4 electron volt. Now will this 3 electron be able to stop
No.
the electron when it receives 4 electron volt? No. Now why? Because this energy is more than the stopping potential.
Yes, sir.
So this electron will go out. But if I say to stop this 4 electron volt electron which is going out, what you should do? You should increase the stopping potential. So at least I should have 4 volt. Now with the increase in frequency, what is happening? My stopping potential is also increasing. So now you can see in the graph, see, for a given intensity, your previous stopping potential was this. Now as I increase the frequency, your stopping potential is also increasing. So I can say that stopping potential is directly proportional to frequency.
Yes, sir.
Fine. So we have studied 2 things. First, effect of what? Intensity on this. As intensity increases,
Current.
photocurrent increases. As we increase the potential, positive potential, what happens? Your
Stopping potential
your
remains the same.
photoelectric current increases, gets saturated. But if I use negative potential and increase it, then your your current decreases, and finally it becomes 0 for a given negative potential. And that negative potential, we call it as stopping potential. And what we have observed, stopping potential is independent of intensity. Even if I increase intensity, my saturation current increases, but stopping potential does not change, remains same, right? So then we have again next, what have I said? What we have said? With the increase in frequency, what happens? Stopping potential also increases. These things you have to remember.